10/5. First of all, is it a test question? Yes, this is a test question. So 315 degrees. So let's go with, I'm going to take my handy dandy document cam. And draw a somewhat of a unit circle, not a whole unit circle, but I'm just going to 315 degrees. Where is 315 degrees? Well, I know it's past 270. So I believe it's 360 minus 45, isn't it? I believe it is. So that means this is 315. That means that this is 45 degrees. So your special angle is a 45-degree angle. We know that X in this direction is positive, so that means this little man has got his foot on the adjacent. Adjacent is equal to positive 1. The hypotenuse is equal to square root of 2. And that means that your opposite is equal to negative 1. So now we're going to do sine. I'm just going to do sine, cosine, and tangent. Well, I better go through everything so that way you can see how to rationalize. And I'm killing two birds with one stone. So here we go. Sine, cosine, tangent, cotangent, secant, and cosecant. Oscar had a hunk of apple. Oscar had negative 1 over the square root of 2. Well, you don't want a radical in the denominator, so I'm going to multiply. I'm going to do this in a light green, so you'll see that I'm doing it square root of 2 over square root of 2. And that's going to give me why isn't it focusing? What's up with that focus? There. And that's going to equal negative square root of 2 over square root of 4, which is 2. So that's your sine. Now, of course, your secant is the reciprocal. And since this is negative 1 over square root of 2, we're going to flip it. And that's going to be negative square root of 2. Now, that square root of 2 is not negative. The negative square root of 2 comes from this negative 1 down here. That's why that's negative. So the cosecant is equal to the negative square root of 2. All right? Adjacent over hypotenuse. 1 over the square root of 2. Square root of 2 down here over 1, which is equal to the square root of 2. And that's going to be multiplied by the square root of 2 over the square root of 2. Which is equal to the square root of 2 over 2. Of apple, negative 1 over 1. One over negative 1. All students take calculus. So which ones are the only ones, the cosine and the secant are the only ones that are positive? Let's look. Cosine is positive and the secant is positive. The rest are negative, so that checks. That is a test question, so make sure you can do it. Who's got a question about it? These are good test questions. I like these because they're short and short. They're short and to the point. They're short. The cos popped and the yod. I would like to ask this though. I didn't watch it, but how did Tom Brady and Zonk, or whatever his name is, how did they do down in Tampa Bay? Are they doing pretty good? I know somebody's a fan of Brady and mediocre. They didn't blow the doors off like everybody thought they would. Well, mediocre. Mediocre. Let's do another question. Well, maybe they need to get acclimated. Let's punch in our answers. Here is going to be the square root of 2 over 2. So that's going to be negative square root. Well, it's not letting me type in a negative. Square root of 2 over 2. Oh my. There. And the cosine is equal to square root of 2 over 2. And the secant is equal to square root of 2. And you should feel good about yourself. Having to switch stuff on my screen, sorry. Fantastic. We feel good about ourselves. So we don't have to put too much makeup on and look like a Oompa Loompa. So that's 9.310. So let's erase that one. 9.314/7. Another good one. Another good test question. I don't mind doing these. I can do these all day long because they're short and to the point. Unless y'all want to do some more confusing ones. All right, so here we go. 120 degrees. 120. Well, this is 90. So that means 120 is going to fall in here somewhere. So what is 90 plus 30? 90 plus 30 is 120. Okay, so what does that mean? That means that this is 30 degrees, so this is 60 degrees. So we got a 60 degrees, which means this is 2, this is the square root of 3, and this is 1. Now the x here, that's going to be negative. The y is going to be positive, and the 2 is always positive. So let's go with sine, cosine, tan, cotan, secant, and cosecant. Oscar had. Oscar had. All students take calculus. All are going to be what? Positive. So we don't have to worry about the signs here. No, I'm sorry. It's in the second quadrant. Sorry. The second is the sine and the what? Cosecant are positive. So that's correct. Okay, now let's do Oscar had a hunk. So that would be square root of 3 over 2. Negative square root of 3 over 2. 2 over square root of 3, which is equal, multiplied by the square root of 3 over the square root of 3. And that's going to be negative 2 square root of 3 over 3. Okay, tan. Oscar had a hunk of apple. -1 over the square root of 3. -1 over the square root of 3 multiplied by the square root of 3 over the square root of 3. And that's going to give us negative square root of 3 over 3. And of course, you flip it. This would be negative square root of 3 over 1, be negative square root of 3. And you're done. So let's punch them in. And this one's going to be not the radical in the denominator. So that's going to be 1 over 2. 1 over 2. And cosine would be negative square root of 3 over 2. Oh, I don't have to do that one. The cotangent is negative square root of 3. Negative square root of 3. And the secant is negative 2 square root of 3. So that's negative 2. Well, I'm just going to delete everything.
Professor,
Negative.
I have a quick question.
Yes.
For finding the 6 trig functions, will the degrees just be from the numbers from the unit circle? Does that make sense what I just said?
Pretty good. Yeah. Yeah, the special angles.
Okay.
Yeah.
Thank you.
That's what, remember me telling you that? Last week I said, if you know the special angles, you can do the unit circle.
Okay, yes, sir. I just didn't know if there was like going to be any other specific degrees that we also had to know the 6 trig
Now,
functions.
we're going to get into the identities in Unit 2. We're going to get into identities on how you find them, but not right now, I don't think. And I've got something wrong. What is that? Negative 2 square root of 3 over 3. I don't know why that one's wrong. Oh, well. -2.
Your tangent and cotangent were the same.
Tangent and cotangent.
And cosine.
I didn't get secant as -2. Okay, did I make a mistake? Somebody help me out. I heard what you said. Say it one more time. What did I do wrong? Did I do something?
You had cotangent as negative square root of 3 instead of negative square root of 3 over 3.
Oh, okay. Oh, well, it's supposed to be right here. What is the?
But they gave you tangent as negative square root of 3.
They also gave you cosine as 1/2 or -1/2.
Okay, 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 I must be 120 degrees is 90 plus 30, right? So if this is 30, then this is 60. Am I not correct there?
Yeah.
Okay. Oh, wait a minute. I think I know what I did wrong. This is supposed to be the square root of 3, and this is supposed to be 1. I think that's what's wrong. I think, is that what you're saying, Mr. Johnson? Yeah. That's what I did wrong. My bad. That's why you need to draw it. If I'd drawn it the way it's supposed to be drawn, with this being small and this being long, I wouldn't have done that. So I made a mistake there. I'm sorry. what needs to be done is this needs to be -1, and this needs to be square root of 3. My mistake. Okay, I'm gonna move on. As long as I know what I did, I'm not worried about it. Okay, next. And that was 9.314. 9.333/17. Okay, find the exact value of the cosecant of pi over 4. Well, I have no idea what the pi over 4 is. So we're going to find out. Okay, what is pi over 4? Because that's what you got to find out first. So pi over 4, I have no idea. So I go pi over 4 is equal to, or multiplied by, 180 over pi, because I want to find out where I'm at. So that gives me 4. I know that 2 will go into 4 2 times. 90. 2 will go into 2 1 time. 2 will go into 90. 45. So this is a 45-degree angle. And it says pi over 4, so that's 45 degrees. So 45 degrees, if you did your 45-degree angle, 1, 1, square root of 2. So sine, cosine, tangent, cotangent, secant, cosecant. Now, if you'll notice, I'm doing everything for this problem. Is that a bad thing, or is that extra practice? I want somebody to say something.
Extra practice.
And no, that's not a bad thing, especially if you suck at this. So I would suggest you do it if you suck at trig, or if you've never had it before, then I would suggest the extra practice. All right. Oscar had there we go. Oscar had, that's going to be 1 over the square root of 2. 1 over the square root of 2, which is equal to square root of 2 over 2. Cosine, A hump, 1 over the square root of 2. 1 over the square root of 2, which is equal to square root of 2 over 2. Of apple, 1 over 1 is equal to 1. 1 over 1 is equal to 1. Square root of 2 over 1, square root of 2, and square root of 2 over 1, square root of 2 over 1, square root of 2. So the cosecant of pi over 4 is square root of 2. Dang old square root of 2, and you feel good about yourself. I like putting those on the test. Remember, the first thing you do in trig is find out where you are. Are you in the first quadrant? Are you in the second quadrant? Are you in the third quadrant? Are you in the fourth quadrant? The next thing you do is make sure you know how many degrees you're talking about, especially if they give you radians. (9.33718). Y'all are sending good questions. They're good test questions. Cosecant of 27 degrees. Well, we can't do this, but we can write it in terms of the cofunction. Now, you got to be careful because 27 degrees is 27 degrees. 27 degrees is like right there. So it looks like to me that the cofunction would be that right there. Okay.
We can't see what you're drawing.
I'm sorry. There we go. So what is the cofunction of 27 degrees, or the reference angle. The reference angle is what? That would be what? 63 degrees? So that would be 63 degrees. Now, I don't know if they want the reference angle, or if they say, well, this is 27 degrees. They might want this. I don't know. Let's see. Cosecant. Well, sine, cosine, tangent, cotangent, secant, cosecant. Okay, now the cofunction of cosecant is the sine. So they might want the sine of 63 degrees. Okay, so it's either they're going to want the sine, probably the sine of 63 degrees. So the sine of 63 degrees. Oh, of the cofunction. I'm sorry. I was thinking of reciprocal. Okay, forget the reciprocal. That's the reciprocal. The cofunction is right here. Sorry. I'm sorry. Okay, I don't do a lot of the cofunctions on a test. I don't do a lot of it because actually you don't use them in real life very much. Okay, so that's the cofunction of cosecant is secant, and that would be 63 degrees because it's what makes up the 90 degrees right here. Sorry. So you do if you start with cosecant, your answer is going to be secant. If you start with cotangent, it's going to be tangent. If you start with tangent, it's going to be cotangent. If you start with cosine, it's going to be sine. If you start with sine, it's going to be cosine. And then it's going to be the reference angle of 27. I'm not too partial to those questions, so you probably won't see very many of these on the test. I don't like to do questions that you don't see either in calculus or real world. So this one you don't see very much in the real world, and you sure don't see it in calculus. Okay. Next, again, that's 9.337. Mr. Michelle, is that good for you?
Yes, sir. Thank you.
Okay. 49/20. 49/20. Reference angle of 318 degrees. Okay. 318 degrees. Let's do that one. 318 degrees. 318 degrees is somewhere in here. Now, since that's 318 degrees, that one's going dead. Then that means that this angle is 360 minus 318. Well, that's 10. That'll be 2. That'll be 35 minus 31 is 4. 42 degrees. And since it's this direction, it might want a negative there. So I get negative 42 degrees. Okay, just write 42. They just want 42. Okay. (9.357/24). Feel like I'm doing y'all's homework for you. The reference angle for 4 pi over 5. I'm not going to do anything until I figure out where 4 pi over 5 is. 4 pi over 5. Because my teacher taught me to find out where I am first. Multiplied by 180 over pi. And of course the pi's cancel. And you're left with degrees. 5 will go into 5 one time. 5 will go into 18 3 times. And that'll leave 30 and that'll be what, 6? Y'all help me out. 36 times 5 equal 180. Somebody check me. And 4 times 36 is 144. So I think it comes out to be 144 degrees. Somebody check me on that. So 144 degrees, well, this is 180. 180 is pi. This is 0 or 2 pi. This is 3 pi over 4. And this is pi over 2. Okay, so 144 is going to be somewhere in here. So that means your reference angle is going to be what? 36 degrees? Y'all check my math. Y'all settle down, please. Now, I got to change 36 into, so that's going to be 36 degrees over 1 multiplied by pi over 180. The degrees cancel, and you're left with pi radians. So let's see, 2 will go in there. Let's see, 2 will go in there 18, or let's see, let's go with 18. 2 will go in there 90. 2 will go in there 9. 2 will go in there 45. 9 will go into 9 one time. I got pi over 5. Now, a lot of people say, why do you go through all that? Because I know how to do it. Okay, and I don't mean that to sound conceited. If you put yourself in the I need to know where I am category, it'll make a whole lot more sense to you. And some of you may have had trig before and you learned it as like regurgitation. This is not regurgitation. This is actually learning the angles. It's actually learning how to manipulate the angles and the radians. And hopefully some of you are catching on to it. I get pi over 5. Let's see if I'm right. Pi divided by 5. And we feel good about ourselves. Now, if you tried to do that by regurgitation, you'd probably leave it blank and go to the next problem. Do y'all know what I'm talking about? Regurgitation teacher versus learning teacher. Hopefully you understand, some of you.
Yeah.
Okay. It kind of helps to know where you are. Kind of helps. That's one of those things you need to learn how to do. All right, next one. Same one. Let's do it again. Same question. The reason I think it's important that you know how to do this is because it basically defines your critical thinking. Look where you are. Then after you look where you are, find out where you are, find the reference angle, then change back to radians. So it's kind of a procedural process. So y'all do this one. 16 pi over 9. 16 pi over 9. All right, give y'all a minute. Shouldn't take y'all more than a minute. Oh, excuse me. All right. So 16 over 9 multiplied by 180 over pi. So I can get the pi's to cancel. Now remember, I'm doing this for people that suck at this. I'm not doing this for those people that invented trigonometry. Okay? I'm doing it for people that suck at it. So just remember that. I know some of y'all don't suck at it, and some of y'all invented and wrote the book. So, all right. So that's going to be 9 will go into 9 one time. 9 will go into 180 20 times. And 2 times 16 is 32 with a 0 is 320 degrees. Somebody check me on that. Oh, y'all did.
That's right.
Thank you. Okay. Now, let's draw it. 320 degrees, 320 degrees, 320 degrees. Be somewhere in here. Well, that means 40 degrees is right here. So there's 40 degrees. So I need to change 40 degrees into, let's see, that would be pi over 180 because I'll get the degrees to cancel. So that's going to be 4 pi over 18, 2 pi over 9. I get 2 pi over 9. Good job.
That's what I got.
Even a blind pig finds an acorn every now and then. Or if you don't understand that, a clock is correct twice a day. A broken clock is correct twice a day. So that means
would you also be able to subtract the reference angle from 2 pi?
Yes, you could do that too.
So you could do 2 pi
but
minus
you would have to,
6 pi over 9.
yeah, and then that's another way of doing it. But the reason I don't teach that is because some students have a hard time understanding pi to begin with. Okay, some students have a hard time understanding 2 pi, so I just do it this way to kind of explain it to them, and then eventually, just like you did, or you may not have, you may have known it before, but some people start saying, say again?
I just noticed it, and that's why I asked.
That's perfect. That's what you're supposed to do. That's what you're supposed to do. You get an A for effort today. Because what you're supposed to do is you're supposed to come to the conclusion, well, heck, why don't I just take 2 pi? Why don't I just do this in blue? Why don't I just take, since this is 0, this is pi over 2, this is pi, this is 3, what is it, 3 pi over 4? I can't remember, 3 pi over 4, and this is 2 pi. Why don't I just take the 16 pi over 9 away from 2 pi? And then I go up here and I say 2 pi over 1 minus 16 pi over 9. Well, I got to get a common denominator. And that's going to be 16 pi. 1 will go into 9. 9 times 2 is 18 pi. 18 minus is 2 pi. And if you come up with this, if you make it from all of this, if you start going to that, then I've done my job. And you feel good about yourself. So you won't have to put smokestacks on your pickup truck, Mr. Michelle. Okay? You don't have smokestacks on your pickup truck, do you?
No, I don't.
Okay, good. Girls, run. Run the opposite direction. 2 pi over 9. 2 pi divided by 9. And we feel good about ourselves. And I guarantee you there's people in here that have never understood how to go from pi to degrees, and hopefully we're killing, hopefully we're killing about 3 birds with 1 stone when we do the pi to degrees back to pi. You're getting a double whammy of it. Okay? Everybody feel good?
Yes, sir.
Okay. Next. That's that one. 9.35724. And those problems we just did are good test questions. Here's another one. Find the reference angle for the angle, 9,5. Now, I'm going to do it both ways. And then hopefully some of you can tie it together. So here we go, 9 pi over 5. 9 pi over 5. Well, I'm going to change that to degrees, so I'll know where I'm at. And the pi's cancel. And 5 will go into 180. 1 time, 5 will go into 180 will go in there 3 times. And what, 6? And then 9 times 36, I have no idea. 9 times 6 is 54. Bring you 5. 9 times 3 is 27. Plus 5 is 32. Somebody help me out there. 324 degrees. 324 degrees is somewhere in here. And I'm going to take my handy dandy, I haven't used, I haven't used this pink in a while. That'll leave this angle right here is the reference angle. 360 minus, well, that's 10, be a 6. And 35 minus 2 is 3. So that'd be 36 degrees. So 36 degrees over 1 multiplied by pi over 180, because I want the degrees to cancel. And divide 36. Well, 36 can be divided by 2. That'd be 18 over 90. And that'd be 9 over 45. And 9 will go into 45 5 times. So I got pi over 5. Now let's do it the other way. Nine pi over 5. And we're going to subtract that, since this is 0 and 2 pi. 2 pi is 360 degrees. So 2 pi minus 9 pi over 5. And that's over 1. So I got to get a common denominator. One will go into 5 times. 5 times 2 is 10 pi. 10 pi minus 9 pi is, look at there, it's a miracle. And I guarantee you somebody's light bulb is going off and going, oh, I see now. It's a miracle. Pi divided by 5. 9377/31. Okay, this is a calculator drill. So I'm going to type in, well, first of all, the secant is what? Let's go back to our handy dandy. The secant sine, cosine, tangent, cotangent, secant, and cosecant. Well, the secant lines up with the what? The secant lines up with the cosine. So I can rewrite the secant as 1 over the what? So secant of theta is equal to 1 over cosine theta. So the secant of 3212, the secant of 3212 is equal to 1 over the cosine of 3212. So take your handy dandy calculator that I just lost. And 1, turn it on first. Make sure it's in degree mode. So mode, and I'm going to go down to degree. Usually it stays on degree mode. All right, so 1 divided by, parentheses, cosine of 32 degrees. So I type in 32, and then I got it. Is it math? No. Second angle, which is apps. There we go. 32 degrees, 12 minutes, 12 second apps, minutes, and close parentheses, and enter. I get 1.18. ... Now let's pull up the question. This is a calculator drill question, so I probably would put this on the test, but we're only talking about 1 or 2 on a test of 20 or 30. Okay, so round to 8 decimal places for real? I don't agree with that. 8 decimal places. Whatever, hold on. Oh, man. Things I do for y'all. Y'all should be appreciative. There we go. 1.18176327. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Well done. How you're not supposed to cook your steaks. All right. Next. This is 9.37731. I feel like I'm doing y'all's homework. Use a calculator for the same thing. Okay, that would be 1 over the cosine. Same thing. So I'm going to go back to my calculator, and I'm going to hit second entry. And I'm just going to type in here 55. This is a trick I learned in the war. 36. 1 point, carry it to 18 decimal places. Hold on a second. 1.18 1488. And you feel good about yourself. Last homework question. And y'all should be able to do y'all's homework. Since I've done it for you. No, I'm just kidding. 9.39/4. I think we've already done this one. But yeah, we've done one like it. 60 degrees. And here we go. 60 degrees is right here. It's in the first quadrant. 60 degrees. That means this is the hypotenuse. This is the adjacent. And this is the opposite. Sine, cosine, tan, cotan, secant, cosecant. Sine, Oscar had, square root of 3/2. A hunk of apple, 1/√3, 2/1, and 2/√3, which is equal to 2√3/3. And that's equal to 2. And this is equal to √3/3. And that's equal to the square root of 3, 1/2, and that. So tan, the tan is equal to, well, you got the tan right, square root of 3/1. They might not like that 1, but that's correct. The cotan is square root of 3/3, that's correct. 2 and 2 square root of 3/3. The only thing that I would say they'd have a fit on is that 1. Let's see. Now I'm going to take the 1 off. Just put square root of 3. That's it. So whoever sent that question, there wasn't anything, you didn't do anything wrong. They just didn't like the 1 under there. And I have just done y'all's homework for you. How many problems did we do in 9.3? I think altogether we did a whole bunch. Now, let's look right quick. I ain't got much time, but let's go back to 9.4. Okay? Let's go to 9.4. Sorry. 9.4. Give me a second. Main menu. I'm just going to go right quick. I'm not even going to look. I think, hold on. I think this is the last section, is it not? 9.4.
There's 9.5 too.
Oh, there is 9.5. Oh, this is 109. Okay. Let me get MyLabs Plus. Sorry. MyLabs Plus. There we go. And on 11. I think this is more applications. I'm pretty sure it is. 9.4. Should be applications. 9.4 and 9.5 is applications, I believe. Yep, applications. Now this is where a lot of your questions are going to come from, and the project that we're supposed to be working on, and I'm going to go ahead and address that today, And Thursday is this section right here. Okay, this is where your project that we have to do that I really don't care nothing about, but we have to do it. It comes from this section. Okay. I'm not worried about that. There we go. All right. Here's a problem right here. Now you're going to have to use your calculator for this. Okay. I'm just telling you. So here we got an equation. I mean, I can't think of the word, triangle. And this triangle is like so. And I'll pull my drawing up in just a minute. We've got an angle of 3430. And we've got C is equal to 12.7 and A and B. Now, when you're doing a problem like this, and you have an angle, the first thing you're going to do is find out what you have beside the angle. Now, our little man is right here because they give us the angle. So that means we have hypotenuse. So that means Oscar had a hunk of apple. Tan, cosine, sine. Now, I'm going to tell you this right now. Most of your practical applications are going to be with these three. Most of them. You don't use you don't use cotangent, secant, and cosecant. The only time you use these three down here is in other calculus courses. So that's why these are important. All right, if you know these, then you're going to know these. And the only time you need these is when you're doing reciprocal identities or other identities having to do with these. Okay, so really, these aren't for practical app. These are for theory. All right, so anyway, which one of these has the hypotenuse in it? Well, I'm going to take my handy dandy. I've got my hypotenuse right here because it's given. So I'm going to have to use either the sine or the cosine. Which one am I not going to use? I'm not going to use the tangent because it doesn't have anything in it. It's got two unknowns in it. The opposite and the adjacent. It's got two unknowns. So the tangent is not going to help me here. So now I'm going to rewrite it. Now you can pick whichever one you want since the opposite. So if the directions say find A, then you would use the sine because it's the opposite. If the directions say find the adjacent, then you would use the cosine because it involves the adjacent. Okay, so I'm going to do both, and you're going to see it gives you the same answer. So here we go. I'm going to do the sine. The sine of 3430 is equal to Oscar, which is O, or in this case A, over 12.7. Now you have an algebraic equation. And the x is right there. So I want to get rid of fraction. I'm going to multiply through by the denominator. And that's going to give me, I'm going to multiply both sides by 12.7. And that's going to give me 12.7 times the sine of 3430 is equal to A. And now you're going to type this in your calculator. So you take your calculator and you type in, and you can type it in as one or two equations. I don't care. I'm going to type in 12.7 times parentheses the cosine of 34 second apps degrees 30 second apps minutes, close parentheses, close parentheses. And that is my A leg, 10.466. A is equal to 10.4664026.
Are you supposed to do the sine of 3430?
Yeah, did you mention?
Did I not do the sine? Oh,
You did the cosine.
I suck. Okay, my bad. Let me go back and change it. I don't know why I did the cosine. There's a sine written right there. I guess I'm just dyslexic. I don't know. All right, so let me hit second entry, and let's change that to sine. Thank you for catching it, though. Give y'all credit. There. So our A is 7.193359209. Now, I want you to give me two ways to find angle B. I'm sorry, side B.
You could
Somebody
use,
give me two ways. You ain't got to tell me mathematically. Just tell me how I can do it.
you could use Pythagorean theorem.
I can use the Pythagorean theorem. That's one. So I'm going to go over here and I'm going to say, I'm going to draw my triangle. Now I've got A. A is equal to 7.193359209. And I would keep that in your calculator. 12.7, 34 degrees, 30 minutes. Okay, now I want to find the opposite, or A, whatever. Did we just find A? I'm getting my A's mixed up.
Yes, sir.
Okay, we just found A. A is over here. I'm sorry. That's why they shouldn't use A and B. They shouldn't use A and B. They should use X and Y. But anyway, A is equal to 7.193359209. Now I want to find B, which is the adjacent. So B, if I use the Pythagorean theorem, it'll be the square root of 12.7 squared minus 7.19 ... squared, and that's going to be B. Okay, you can do it that way using the Pythagorean theorem. Or think about it. What do we have? Well, I can use the cosine. Oscar had A, that's the adjacent, over 12.7. So I can use the cosine if I want to do that. So the cosine of 3430 is equal to Oscar had A over 12.7. And that's what I had a while ago. So the cosine, so 12.7 times the cosine of 3430 is equal to B. And I think that was where I got my 10. So second, enter. And I'm going to put a cosine right here. and enter. And that would give me 10.4664026, and that would also be your answer there. Now, in order for you to make a good grade on this test, you will need to ace these questions on, I don't forget what section we on, what chapter? 9.4. 9.4 is going to make up a good portion of your test. So even though we just started on it today, I want you to go home and I want you to work on the problems, send them in, and then whenever you get to a point you can't go any further, just stop, okay, because we haven't covered everything. But you should be able to start on some problems if you have had trig before or if you understood what I did today. If not, send the questions to me or wait until Thursday and we'll finish 9.4 and probably start on 9.5. Are you noticing that we are getting toward the end of the Unit 1? Have y'all noticed that? Yes, we have. And that means we're getting close to a test. And that will be on the review. And so it's going to be kind of a either 2 tests or 1 big test. But we'll go over that when we go over the preview. All right, so let me go to the handy dandy enrollment. Let me cut that off, cut the recording off, and let me go to the enrollment.